Okay, so in this video we're going to be doing trigonomic ratios of acute triangles. So if you remember, acute are angles that are less than 90 degrees. So when we are dealing with angles that are less than 90 degrees, that means we have one angle that is 90 degree in the triangle. Well, not necessarily, but what we're going to be doing in terms of trig ratios, just to recap. SOHCAHTOA, sine, opposite, hypotenuse, cos, tan, and A is adjacent, and hypotenuse, and O is opposite. So we have our SOH, sine theta is equal to opposite over hypotenuse, cos theta is adjacent over hypotenuse, tan theta is opposite over adjacent. So now that we have our trig ratios, we can look at an example like that one. Say we have an angle of 16.7 degrees. And I want to find out, let's say I have a 3 meter height here. I want to find out this guy right here. Let's call this x. So let's say I want to find that out. So I'm going to be using my tan ratio because I have an angle and then I have the opposite and I'm looking for the adjacent. So I can do tan theta equals O over A, which tan theta is equal. This will now be written as tan of 16.7 degrees is equal to opposite, which is 3 over x. So now if we were to rearrange this, we can put this as x equals over tan 16.7 degrees. And if we were to punch this into the calculator, say we do that, I have tan of 16.7 is 0.3, and if I do 3 over that, I get 9.9999, which is about 10. So our x is equal to 10. So if you have something that is 10 meters long and 3 meters high, or 10 meters away and 3 meters high, the tip of that to here is going to be 16.7 degrees. And yeah, like, this video is kind of more of a recap of things that we have done in the past. So let's say we have another problem where we have this triangle 28, and this is a right angle. So say I want to find out this length here, and again, as a recap of what we used to do in the past, this is basically one of those A 20 squared is 400, 8 squared is 64, so 464, and c is equal to the square root of that. So I would end up with about 21.5. And now we have three different angles here. Sorry, that one's 90. But we have these two, theta 1 and theta 2. And I could actually start solving for these. Say I wanted to solve for this one, theta 2. I know that the tan of theta 2 is opposite over opposite, which is 8 over 20. So I can put that in. 8 over 20 is about 0.4. So tan of theta 2 is 0.4. And if I was to punch that into the calculator, I could do inverse tan of 0.4. I get about 21.8. I can round that too. That's how I write, or you write, everybody writes inverse tan. And now I have 21.8. Now, I could actually use another trig ratio to find this one. I could do the tan of this one and make that the opposite, and that's the adjacent. Or I could do a cos, where this is the adjacent and that's the hypotenuse, or opposite and hypotenuse. I could use each one of them. Or I can do the rule where the angles inside a triangle all add up to 180 degrees. So 90 plus 21.8 plus I have theta 2, I'm looking for theta 1 is equal to 180, so theta 1 is equal to 180 minus 90 minus 21.8. So that is going to give me 68.2 degrees. And I don't know if we have gone over reciprocal functions, but let's introduce them here. I doubt we have. But basically, when we have something like sine theta, there is a reciprocal function of this, which is cosine, the word is literally slipping my mind right now. CSC. I believe it's cosec. No, yeah. I'll have to come back to that. And for our cos theta, our inverse is sec theta, and for our tan theta, our inverse is cot theta, and CSC is the same as, or is equal to 1 over sine theta. That's what the reciprocal is. As our sec theta is 1 over cos, and our cot theta, cotan, is 1 over tan theta. So while you might remember sine theta is opposite over hypotenuse, CSC theta is the reciprocal. So our hypotenuse over our opposite, while cos theta was our adjacent over our hypotenuse. The reciprocal is now our hypotenuse over our adjacent. And while our tan theta was opposite over adjacent, our cotan theta is now adjacent over our opposite. So these are our 6 trig identity or functions, our ratios, our sine theta, our sine, our sine, cosine, and tan theta. And then we had our reciprocal functions here. 1 over sine CSC theta, sec theta, and cotan theta. So, I hope you remember these because we're going to be using them in the future in much more confusing ways. So for now, that's all for this introductory video to these trig ratios, and I shall see you in the next one.